So welcome back to a new video. On this video I will show you how to manually overclock the Core i9 9900KF step by step on the EVGA Z390 Dark. So this is the stripped down version of the 9900K. They are both exactly the same CPUs. The only difference between the two is that the 9900KF lacks the integrated graphics controller unit, the so-called iGPU, but otherwise they are exactly the same. Their price tag is pretty much the same, and the whole overclocking process is pretty much identical to the 9900K. So here you can see I'm in the BIOS. I'm using the BIOS 0.92, which is the custom beta BIOS which has XP support. This is quite nice for overclocking purposes. So it's pretty straightforward. What I actually do now, when we integrated some of our profiles to the BIOS, I would just go to the extras, then press down arrow key and click on OC profiles and load my 4200 CAS17 5.2 GHz daily profile. So we can use this profile mostly, so we can just start at 5 GHz with 4.5 on the cache. I will use 0 AVX ratio offset now for testing purposes, but when it comes to daily overclocking, I would recommend that you have a value of, let's say, like 2 to 3 on the AVX negative offset. So this will help you to maintain stability in applications that can utilize the AVX instruction sets, as those will consume a lot more power than non-AVX applications, and it is much easier to maintain stability when the core speed is dropped for those specific tests, and it's also a little bit easier to maintain the temperatures, as those applications and the AVX stress overall will increase your CPU temperatures by quite a lot. So here I will just use 100 base clock. I do not touch that. Do not enable extreme voltage mode. It is not needed at all for daily use. The only real case when you have to enable this, even on water cooling, is if you want to test like really tight memory timings, like you must use over 1.6 on the DRAM voltage. Then you have to enable this in order to use like 2 volts on the memory, but otherwise just keep this disabled for daily use. vCore, I personally use override for most of the main testing. It is even safe to use for daily use, but of course adaptive would be maybe better option in the long run, as that will make sure that the vCore will go down when the CPU is running idle. Now I will use override mode and I will set vCore target value of 1.3 volts. I recommend that you do not use any more higher vCore as a starting point, as these CPUs do get quite hot, and also the 9900KF seems to run more hot than the other 8-core CPUs that I have here. So this CPU will get to very high temperatures fairly quickly, even on very strong water cooling custom loop. So use like 1.2 to 1.3 as a good starting point. vCore vDroop, so-called load line calibration. The whole idea with load line calibration is that you want to have the vCore very constant to this set value, so you don't want the vCore to drop that much under load. So for example, if you set 1.35 in the BIOS, you don't want that the vCore will drop to like 1.28 or even 1.26 under load, as that will make the CPU to crash. But you also don't want the vCore to overshoot a lot when the CPU goes under load. So if you set 1.35, it's not so nice if the CPU will overshoot to like 1.42 or 1.43 when under load. So you want the vCore to be roughly the same, both when it's idle and also under load. I recommend that you use minus 50% small droop option. This will guarantee that the vCore will always be around the same. The load value will be a tiny touch over the set value. So if I set 1.3 volts, the value under load will be like 1.31, so it's extremely close to the set value, and there will be no voltage drop under load. vCore PWM frequency, you can use a value from 300 to 800 here. Do not use a value over 800. Those will be removed, or they are already removed in some of the newest BIOSes, as a value over 800 only gives some weird issues, and it will only make the end result worse. So I personally use 800 for most of the time, even on watercooling and on LN2, so you can set that. Keep the vCore guard band enabled. VCCSA and VCCIO, these are very important for memory overclocking. I think that you can use a value of 1.25 fairly safely here. If you leave these two auto and you, for example, try to run very high memories like 4300 or even over, then sometimes the BIOS might set a very high value on both of these two when they are left at auto, like 1.4 volts or around that value. So it doesn't sound so safe to run so high value in the long run. So I always set these two manually. You can use 1.25 quite happily with my profile, and the rest of the voltages are not needed. I just sometimes set the PCA voltage manually. There was a time back in the day when I saw the PCA voltage go up to weird values when it was left on auto on some motherboard bundle, and since then I've always set it manually to near the stock value, so I can be sure that it will not go up when it's left at auto. So yeah, in the memory section we can my profile works very well from like 4133 to 4300 with these set timings. Memory voltage value up to 1.5 is absolutely fine. There are memory kits out there that have 1.5 as rated stock value, and the manufacturers offer lifetime warranty with that voltage, so we can be absolutely sure that running 1.5 is very safe for the memory sticks themselves. But sometimes too high memory value can actually be worse when it comes to stability. So now I will use a value of 4133 with 1.45 on the memory voltage. But same timing, so 17, 18, 18, 28, command rate 2. This is the Kingston HyperX Predator 4133 A2 PCP kit, which I've been using quite a lot recently in my videos. And then some of the subtimings have also been set. So yeah, that's pretty much it. I will use Windows Server 2012 for testing purposes, so I have set the boot mode select to legacy. But of course, if you are installing Windows 10 from a USB stick, then keep this at UEFI. Yeah, we can now press F10 and then get to the operating system. And here I'm now in the OS. I'm using the same operating system which I used for some of the records on the 7350K, but it doesn't really matter. So I will use Cinebench to test the CPU stability, and I will use the custom stripped down version of Elite software to change the clock speeds on the fly. So now if we open CPU Z, we can see that the CPU is running at 5 GHz. The CPU Z voltage value must never be like trusted too much. It is not accurate. You should always verify the load line calibration setting with a multimeter if you want to be absolutely sure what voltage you are running. But we can see that all cores and threads are being used. 9900 KF arrow stepping in the revision part of the CPU Z, and memory is running at 4133, 17, 18, 18, 28 common rate 2, and 4.5 on the cache EVGA Z390 Dark. So from here we can just start testing the stability and temperatures with Cinebench, and I will monitor the core temperatures with core temp, as it's very light and it really seems so easy to use compared to some other software that really use a lot of system resources. I don't like them. For example, hardware info and those applications. So now we can see on core temp that the temperatures are already quite high, even on idle. So the minimums are just over 30 degrees. So it's exactly what I said. The 9900 KF really runs very hot compared to my 9900K CPU samples. So that is also one of the reasons why this cannot hit so high clock speed compared to the best 9900K CPU samples that I've had here. So we can now just start Cinebench R15 and see. Yeah, if you read on CPU-Z, the vCore value is just reading all over the place, so this is not a real value. You can use the onboard debug LED on the Z390 Dark to monitor the accurate vCore value. So even that is very accurate if you don't want to use a digital multimeter, or if you cannot use one to check the actual vCore. But now you can already see that the maximum core temperatures went like just over 70 degrees as an average value for the core maximum. So that is already quite high temperature. So now we can open Elite again. I will of course put links for these all this software, so you can download them yourself. The Elite stripped down version is not available at the official EVGA website. It is available at the EVGA OC Lab forums, but I will provide a link in the description below. So now we can use Elite to change the ring value, the so-called cache, to 4.7. We can hit apply, and boom, we can read in CPU-Z that the cache is now at 4.7 GHz. So now we can try if 5.1 is stable with the same voltage. So we can just apply it, and we can see that CPU-Z is measuring 5.1 GHz for the 9900K. So now we can start Cinebench R15 again. The temperatures are slightly higher than in the previous run, as changing core speed does increase the current that the CPU draws. So not only the voltage affects CPU temperatures, the clock speeds do affect CPU temperatures as well. You can test this yourself by running, for example, any test like Cinebench R15 with 1.35 set voltage at 5 GHz. Then you can flip the slow mode switch on the motherboard, which will drop the CPU multiplier to 800 MHz or 1200 MHz. It varies a little bit on some motherboards. And then you can run it again at the same voltage, and you can immediately see that the core temperatures are much lower, like 20 to 30 degrees lower, when the CPU is running very low clock speed. It's also only because the CPU just draws less current in amps than at the maximum set core speed. So 5.1 was stable, as well as 4.7 on the cache. Then we can just open Elite again and set core speed to 5.2 GHz. But overall, these temperatures are already quite high. So if I wanted to run, let's say, Prime 95 or any other AVX, so AVX test with these settings, the temperatures would immediately go like 80 plus or even close to 90 degrees. So that's why I wanted to say that be extremely cautious when you start testing these CPUs. Even when they are soldered, they still run fairly hot. and we already saw the tests from debauer and similar that deleted 9900K or KF with liquid metal will run cooler than soldered with the IHS being soldered. But since I sometimes use LN2, I will keep the solder there, as it is better for LN2 than a normal conventional thermal paste. We cannot use liquid metal on LN2 or any form of sub-zero cooling, so that's why I do not delete these CPUs myself. I could maybe delete some very bad CPU sample only to test the temperature differences myself, but yeah, now I have set 5.2 GHz in CPU Z. We can test the CPU stability again. So now we can start running Cinebench again with 5.2 GHz. So we can already see that the temperatures are going up slowly, but they are still going up anyway. So like this is already 2 degrees more than in the previous run. So it's already quite high. So the score is 2 to 30. It's quite okay. If you can pass 5.2 GHz with 1.3 set vCore, it's already quite good result. It is not among the best. The best CPUs will hit 5.4 to 5.5 GHz for Cinebench with a little bit over 1.3 volts with very strong water cooling, as I have already demoed this with the few chips I've had here. So now we can try 5.3 GHz, but this will crash, I can guarantee. So 5.3 was already the maximum I got out of this CPU on water cooling last time. So yeah, we can already see that the maximum core temperatures are peaking around 75 as average, like 74. So I would be quite scared to run AVX2 applications with these settings, and that's why the AVX negative offset is very handy when it comes to daily use. So now we can see it crashed straight away. So here we can just go back in the BIOS, increase vCore a little bit, and we can see if the CPU will pass 5.3 with like 1.35 set value. But this already shows that this CPU will not pass, like, well, it definitely will not pass 5.5 GHz on normal water cooling. 5.4 could be very on the edge if I had very cool, like ambient room temperature, and that would also require very high vCore. So we can just go back into the BIOS and increase the CPU vCore to 1.35 and see if we can pass the 5.3 GHz test this time. We can also just change the call speed for that test already, so we don't have to mess around with ELEAD. Hit F10 and save and exit. So we can see on CPU Z that the CPU is running at 5.3 GHz, and again the vCore value is just reading something odd. It's not reading the actual vCore, it's only reading the VID value. So cache is at 4.7, and we can also notice that the idle temperatures have gone up again. So we can now open Cinebench R15 and see if this is anywhere near stable, but of course the CPU temperatures will be even higher now as we increase the vCore from 1.3 to 1.35. Seems to run, but the core temperatures are already around 80 degrees. This KF really runs like 5 to 8 degrees harder than my best 9900K samples, and it crashed. Yeah, it's weird. The next attempt it might pass, and so it's very on the edge, but it definitely will pass around that vCore value. So 5.3 is definitely the maximum this will do for something like Cinebench. It will not do 5.3 with, 5.3 stable in AVX applications. That is absolutely sure. So the score is 2290. It is very on the edge as it required 3 attempts in order to pass it. So, but we can say that it is somewhat stable. So 5.3 GHz requires somewhat around 1.35 vCore when the room temperature, my room temperature is actually quite high. It's around 27 degrees. The very high idle temperatures already show that I have very high room temperature. So so that is pretty much the maximum this CPU will do. So if I try to test this for like daily stability, I would drop the CPU back to like 5.1 to 5.2 GHz with lower voltage like 1.3. Then I would run at least a few hours of Prime 95 26.6 or a little bit newer version that supports AVX and see if it's stable. Of course, if it can utilize the newer AVX offsets, it will run very high temperatures. So if you hit already like 70 degrees in Cinebench, AVX to Prime 95 will hit like 90 degrees or so. That is very high CPU temperature. So be very cautious if you test with Prime 95. So, but that's why it's very nice to utilize the AVX negative offset. So I could just run, let's say like 5.2 GHz with 1.3 or a little bit over 1.3 volts for non-AVX applications. Then I could just drop the CPU clock speed to 5 GHz. So use a negative offset multiplier of 2 for all applications that can utilize the AVX offset. For memory, I have already shown you many times that you should use HEI memory test to test the entire capacity of the memory you have installed. So as we have 16 gigabytes here, we should open as many windows of HEI mem test to test in the entire capacity of the memory. But when I was making this daily profile, I already tested speeds of 4133, 4200, 4300 with this exact memory kit with HEI mem test, and I was able to pass even that test with the entire capacity even at 4300. So that is definitely a very reliable way to test. It is more reliable than something like SuperPi 32M and or even HyperPi 32M or the ADA64 memory test, as the HEI mem test will stress the entire capacity, not just run some hard calculations for the memory controller as well as for the memory. But yeah, so overclocking the 8-core Coffee Lake CPUs is very straightforward on the Z390 Dark. You can also use the Elite software to change the vCore value, but it's not very reliable. So here I can drop the CPU multiplier back to 5.2 and use the Elite to drop the vCore from for some reason it's not offering the current set value, the software, so I just have to select 1.3 from the list, of course. But now we can see it's running at 5.2 GHz, but we don't have a very reliable way to monitor the vCore, so we cannot show that it's running at its current set value, what I just set. But we can prove that with core temp and see that the core temperatures have dropped down back to those temperatures we previously had. So now they are not hitting 80 degrees or even over that. So it's exactly the same where we just were. But yeah, if you have more questions about overclocking these CPUs on the Z390 Dark, then please give a comment down below and subscribe to my channel, and see you next time.